Hello everyone. So today we're going to discuss the scope of software engineering. Okay? So before that, these are the learning objectives of this topic. Right? So number one, understand what software engineering is and why it is important. Number two, understand that the development of different types of software systems may require different software engineering techniques. Number three, understand some ethical and professional issues that are important for software engineers. And number four, understand the scope of software engineering. Now, what is software engineering? Okay, so the term software engineering is composed of two words, software and engineering. Okay, so let's talk about the software first. If you say software, it is more than just a program code. If you say program, a program is an executable code which serves some computational purpose. Okay? So software is considered to be a collection of executable programs, associated libraries, and documentation. If you're going to develop a software or you are made for specific requirements, we call it software product. On the other hand, engineering is all about the developing products using well-defined scientific principles and methods. Therefore, we can define software engineering as an engineering branch associated with the development of software product using well-defined scientific principles, methods, and procedures. So the outcome of software engineering is an efficient and reliable software product. Okay? So another thing is software engineering. It is a discipline whose aim is the production of software that meets the client's needs, fault-free, delivered on time, delivered within the budget, and lastly, it's easy to modify. Now, why the need for software engineering? Take note that a small program can be written without using software engineering principles. But if you want to develop a large software product, then software engineering principles are absolutely necessary to achieve a good quality software. Without using software engineering principles, it will be difficult to develop a large programs, especially in industry, which is usually needed to develop a large programs to accommodate multiple functions. The problem with developing such large commercial programs is that the complexity and difficulty levels of programs increase exponentially with their sizes. So, software engineering helps to reduce this programming complexity. So, software engineering principles use two important techniques to reduce those problem complexity. So, this is the abstraction and the Docker position. Now, let's talk about the characteristic of a good software. Okay, so when we can say that a software is a good software product, okay, a software product actually can be judged by what it offers and how well it can be used. Okay, so this software must satisfy on the following grounds: operational, transitional, maintenance. Now, operational. If we say operational, of course, this tells us how well software works in operation, and it can be measured on budget, usability, efficiency, correctness, functionality, dependability, security, and safety transitional. Okay? Another thing is transitional. Okay? A good software should be transitional. If you say transitional, this aspect is important when the software is moved from one platform to another. Okay? And lastly, the maintenance. Okay? If you say maintenance, right? So this aspect briefs about how the software has the capabilities to maintain itself in every changing environment. Okay? So in short, software engineering is a branch of computer science which uses well-defined engineering concepts required to produce efficient, durable, scalable, in budget, and on-time software products. Now, let's talk about the software life cycle or the stages in developing a software product. Okay, so the first stage is the requirements gathering. In this stage, you're going to gather information. Okay, you gather information, you do requirements gathering. So after that, the next stage is the analysis or the specification. So you're going to draw off your plan. You're going to create your plan. for your software development or for the product or for the software product that you want to develop. After the planning, of course, the design. During the design stage, you're going to lay out not only the interface of your system or your software, at the same time, the overall design of your database and the system design itself. After design, of course, you're going to start the implementation, which is the hard coding. Okay? So hard coding, you do testing, you do integration, at the same time, the deployment. Okay? So after the deployment, of course, the post-delivery maintenance, store and maintenance. Okay? So any changes additional for the system that you develop, and after that, the retirement.